Hello, everybody. Welcome to day two of Build with Mapbox. Very happy to have you here. We're going to have a great session today. Shray is going to be talking about our features for EV. We'll just give folks a few minutes to join. We've got some attendees coming in, so we'll just give them a couple more minutes. In the meantime, if you click the chat button at the bottom of your window there, we'd love to hear about your EV experience. Let us know if you're driving an EV right now. I mean, not literally right now, but if you if you own an EV, let us know if you are an EV driver. We'll just give folks a minute or two. How about you, Shrey? I think you have an EV, don't you?
Yeah, I've been an EV driver for a long time. I've been rotating between different EVs through leases. We have EVs from work. The one I usually test right now is like Rivian, the R1S, which is really cool.
Very cool. Well, I think it's appropriate that you drive an EV because this is your work is all about the EV experience. So, that's very important. Okay, I think we're going to get rolling here. If you want to advance to the next slide. Hi, everyone. I'm David Snyderman. I lead product marketing for automotive and navigation here at Mapbox. And today, Shrey is going to talk about supercharging your EV experience with Mapbox. We've got some really cool, thoughtful features to support the EV experience. Shrey will walk you through that. Shrey is a senior product manager here at Mapbox and focusing on EV. And Shrey, I'll let you take it away.
Awesome. Hey, Shray here. I'm a product manager in navigation at Mapbox. We're going to talk about EV. What should we do different for EV drivers when it comes to navigation? So I've got a small agenda for today. Very excited. We'll go through some trends at the beginning, just to see level set what we see out there in the market. We're going to talk about some solutions that Mapbox has. I'll also be sharing some live demos with playgrounds, what you have today that you can actually get started and get your hands on. And we'll wrap it up with some new cool features we released recently and how you can sign up. With that, I'll move over to trends. Electrification is a big trend. We see it's happening everywhere across all forms of mobility, and we know it's happening very fast. And not just today, but it's happening for years now. And we see this as a transformation not only in the automotive industry, but also fleets for commercials, right from first mile to last mile deliveries. We also see electrification happening for the urban mobility sector, which is e-rides based on bikes, mopeds, scooters, you name it. And you see electric vehicles in major cities across the world. The common goal we know is you need to bring sustainability to the community, mobility for everyone, improve the cost effectiveness, and help the planet have lower carbon footprint. Uh, regardless of how popular EVs are getting, there are a lot of challenges. People who have been driving EVs can resonate more. We know that when you go out and charge your cars, the chargers can be broken sometimes. They are slow. Sometimes they don't even work with your vehicles because they're incompatible. And if you are driving in cities like California, New York, you see these are just like overcrowded in many cases. And to make the matters worse, the payments. That's a different story. Some stations don't even accept credit card, debit cards. Some just do plug-in charge. So the experience is like very skewed across different region where you're charging. And like one spot can work at a location, the other spot may not work. These are the common complaints we hear from people on the ground. And to make it even worse, we see people have to have like half a dozen apps on their phone. Very common in Europe, we see, where people just have to have different apps and subscriptions plans just to pay for charging. Sometimes we even get anxious just thinking about all these issues. And we expect this problem to even get worse. It's not going to ease unless we find some kind of a platform-centric approach or and have more roaming capabilities across these CPOs. Um, with that, what's an EV driver thinks about? We did a lot of conversations with folks, our customers, people who drive EVs. We know standard navigation that people are more aware of, like getting routes from point A to point B, traffic, live updates. A standard navigation like that is not sufficient. When you talk to car owners who are thinking of switching to an EV or even just new EV owners, we hear some repeat concerns. Like the questions are very simple, like, hey, I know how to fill up a tank with gas or petrol, but I don't know how to find chargers nearby, like which app to use. People are still in that early stage of that learning curve, which some EV drivers like feel very anxious about. How will I pay for charging? People think about, hey, I always go to this weekend trip. Can I make the journey back with my current charge? Like, or do I have to scramble back to find a station when I'm coming back from my trip? Long trips are even uh, riskier for folks. They think there are a lot of EV route planners in modern cars and apps, but how do you actually use it? How to actually make it work for your vehicle, for your context? Especially when you're going to new regions, new locations, you already are thinking about the trip, and you should not be worrying about the vehicle and how to charge the vehicle and make it work for you. Uh, Very common complaints, and this is the solution that Mapbox has been working. We call it Mapbox for EV. It's a collection of products in APIs and SDKs that you can actually start building today. It's already available. You have to sign up. There are four key solutions that we are trying to target. First one, top left, is discovering of charging stations. So you want to find stations that are compatible with your vehicle, your user preferences around you or near your destinations. You would want to find stations that are like available, they meet your brand preference, you want to find free chargers, you want to find stations with particular kind of a coffee spot or coffee places around. You can do all of this with Mapbox EV APIs. And this works on top of the existing maps canvas that Mapbox has. So each UI element that you see, you can like charge a pin. You can customize it to reflect any information that you like charging speeds, what you see here on the screen, like 3 sparks versus 1 spark, what you see on the top left. So all of that like works in tandem. The second experience is range prediction. To help with range anxiety, EV drivers want to know a precise range on arrival. So what Mapbox does is we bring the relevant content from the vehicle and the live location data like traffic and road conditions and road elevation and mix it with the driver behavior and the vehicle characteristics to create a very unique, precise precision along your trip ahead. So it's not a historical looking prediction, but more forward looking at the actual trip ahead. Third experience, trip planning. This is very common of like a typical long distance journey. People would go on like 400-mile trip. EV drivers today, what they do in the absence of a really sophisticated route planner, people would actually go and open apps and manually scan through screens and see like 100 plus fast chargers on the map. And then they're trying to figure out how to pick a stop, how many stops. And this is quite painful. So we can do this in a single API, in this existing directions API, which is our routing API, and it can give you the fastest charges along the way. Uh, the last piece is data. Like number one complaint, we know stations are broken, unreliable. How do we make sure that if I go there at a charging spot recommended, will I be able to charge or not? We know the importance of getting the charging data right. So what Mapbox does is we have our own platform of feedback and corrections that we work to bring together into a Mapbox that's a unified kind of platform where we look at vehicles telemetry, we look at charging sessions, we look at user feedback, and bring and work on correcting the location of the charging stations. Instead of front alley of the road, it's in the back alley. And what you see on the top right is one example. And we work also with our data partners to go and fix this data for us. With that, I'd love to switch over to a quick demo to show how this all comes together. We're going to look at first demo on Mapbox docs page. This is called EV Charge Finder API Playground. This is available today. So if you press a pin, place a pin anywhere on the map, it'll give you stations around you. So green here means stations that are like available. So you can go and charge there. It also gives you the brand name, say Ubitricity. Blue icons here means stations that are busy. So there are no stations on this location available. One of them is red, which means it's unavailable. Probably it is removed or temporarily out of service. Blue means it's busy. So there's no station that's available for drivers to actually go choose. Gray here means station is unavailable, which means it is, sorry, status is unknown, which means either the station is not hooked up to the network, so you don't even get live status updates, or the network is down for this particular station. We're not getting live feed from the backend. So you get this information real time at every API call. Let's look at a common use case. So you have these parameters here on the left-hand side, which are reflecting the API options. So let's say I want to find a charging station, say in 2 kilometers. I want to find top 20 stations, and you get this list. I want to charge now. I'm low on charge. You can see here there are stations which are busy. So I'm going to say, oh, only give me stations that are available. I'm going to change the availability filter here, and I only get green stations, which means these are all available stations. And then I can pick and obviously go and route to them. One thing you'll notice here is these are all nearby stations. So they're like slow. These are only slow power stations, 5 kilowatt, 4 kilowatt. So I want to find stations that are fast enough. So I know I want to find, I like to charge on certain operators, which means the brands are like BP Pulse. So I'll type here. I know I also like to charge on Teslas, where I get a good experience. I charge fast enough. So immediately you can see, oh, these are like fast power stops. I also get Teslas over here, 250. This is great. My car can actually charge, say, Tesla. So I'm going to say, oh, let's only find Tesla spots for now. And when I do this filter, I only get Tesla. One additional thing that we also support is exclusion of Tesla stations. So we know Teslas have opened a lot of the supercharger networks to all EVs, but not all. So there are still a lot of Tesla superchargers that are still not open to many EVs because of their firmware upgrade. So we keep that data also. And you can say, don't give me stations where I cannot actually charge. And you'll see here, you'll get one Tesla supercharger in this location, which looks great. And you can actually, it's eligible for your EV, so you can go and charge there. The other example I can show here is amenities. We get questions about, hey, I want to go and charge, but I also want to spend time, like maybe eating or finding like a restaurant. So you can have amenity filters here, which is, and you get different stations recommended here. Other filters, common ones are, I want to go and have a restroom access for a family trip. You can have those as well. If you're in a cold climate and it's snowing and it's not great weather outdoors, we know charging happens mostly outdoors in many places. We also have the filter for roof. So you will have stations that are covered by a roof, so you don't stay in the snowfall. And you can get different charging recommendations that you see here. We also have payment filters. The one common one is ad hoc, what we call, which means I'm on the ground, on the road. I'm not carrying subscription apps or cards. I just want to go and just pay with my credit or debit card. So you can have those filters also available. And immediately you can see you get slightly different flavor of operators like Light Energy and MFG. All right, that was a demo on Charge Finder. The next demo I have for you is the range prediction. Fortunately, this is also available as an API playground, where you would, in this case, you would go actually to EV directions API on the top right screen. And this directions API has a mode called EV, electric. So if you switch there, you will immediately get trips with EV information. So when I build this trip out, we have a preset for electric vehicle called sedan. It's a fixed model that we have put for playground purposes. It's a 70 kilowatt hour battery pack. What you see different here is this colored line along the route, which tells you about what will be your range on arrival. So it's saying 41% here, which means you start at 80 and you go down to 41% on here. This is color graded, so you can see different SOC arrival pieces. What I can do next is, right now we are simulating a scenario where you start with 80%. You can also change this to 35 1000 here, which is essentially 50% charge. And now you get a different SOC on arrival. Say it's a cold climate and you'll be turning on heat conditioning. So your auxiliary consumption, which is your fixed consumption in your vehicle, you would be enabling, say, at 2.5 kilowatt you'll be spending. In this case, you can still make the trip, but you'll be arriving with pretty low charge at the end of the journey. One common example I see is we can make the forward trip, but what about return? Can I come back? So let's say if I add a third waypoint, which I added here, you can see this icon here which says end of EV range. So this is really, really useful. So if I zoom in here, I can see there's two route lines going forward, which is the bottom line, and on the return journey, which is the top line, I see a point where it is predicted that you would run out of range if you follow this route somewhere around this. So you would need a charging stop. And these are all API parameters which are flexible, and you can model your EV of any type with this consumption curves, which is a non-linear curve. Your mid speeds, you're much more efficient. In high speeds, you are consuming more energy, and you can model this flexibly for any EVs if you have that information. All right, that's the demo on range. I can quickly also show you a small demo on trip planning. I'll head over to the same API. And in this case, what I'm going to do is I'm going to select my connector type, which is type 1. I'm in US. Type 1 connector is the predominant one after Tesla, of course. So I'm going to make a little bit longer trip here, say Washington, DC to New York. And in this case, at runtime, what you saw, the API calculated the route. It figured out you can't make the trip with range, sufficient range, and it searched for charging stop, and it recommended you one somewhere here near Philadelphia. So you can say it has picked up the Tesla charging station, which is the fastest one. That is the recommended one. You need to charge for 6 minutes from 28% on arrival. And it is also giving you a recommendation of how much you should charge. So charge to 45%. You can obviously charge more if you want. It'll just increase your trip time. The constraint it is trying to solve for is what's your preference of how much you need to arrive at your destination. So by default, it's set at 15%. So you just need to charge enough to arrive at 15. I can change that in these API. There are parameters for almost everything. So I can say, hey, I need to arrive there by at least 50% charge because I would spend time there roaming the city around. And immediately what you see is the same stop, still the same recommendation, but your charging time has increased from 6 minutes to 27. If I switch this to a hatchback, just for the fun of it, we also have a model for hatchback, which is a smaller battery size. So instead of 70 kilowatt hour, we have a model of 40 kilowatt hour. It has a different charging curve, charges slowly, but you can see it's a smaller battery, charges slow, so you need to have two stops instead of one. And that also comes through like one single API call from Mapbox. All right, with that, I think that concludes the two demos we had. I'll spend the next 2 minutes talking about a couple of features that we recently launched. One of them is Range Map. It's a very cool feature. If you're like me and you want to quickly see how far you can go on a current charge, you can now press a button and instantly visualize the whole range on the map, how far you can go. Very good for planning intercity trips without worrying about precise range, just to see how much you have, how far you can go. The current support level is about 1,000 kilometers, and most of the times, even for like large ranges, the API response time is within 3 seconds, so it's optimized for really fast speeds. One really good use case for range is supplementing those pesky low fuel range reminder that you see in ICE vehicles. People ignore because it's so easy to refuel along the way. But for EV, what you can do is in complementing to the low gauge reminder, you can also add a range map with red colors of your choice, and you can show what are the charging stations with fits within your range, drivable range as you're heading towards the low side of the range. The last feature we launched recently is available in our Mapbox SDKs. is trip alerts. So we don't stop at trip planning. On Mapbox side, we also connect with your vehicle and give you alerts as your battery status changes. So if you don't have a charging stop at the beginning of your trip, say you're driving much faster, you can't make it within the trip because you turned on the air conditioning and you're driving more aggressively than expected, we can detect those scenarios and recommend you, hey, you are better off stopping at a charging spot, and this is the stop that we recommend with the detour time and charging time. So this comes by default with the SDK. We also track charger status, infrastructure, not just vehicle. So if you're like me living in California, EV stations can get very busy very quickly. So you may have a charging stop planned, but as you're about to arrive, station is full. We can detect that and recommend you probably get a different charging stop recommendations. All right, that brings us to the end. How to get started? You can request access to test any of these EV products or all of the EV products today by signing up on Mapbox website. I will paste the link in chat for folks to access this. And there it is. With that, we are end. Over to you, David.
Very good. Thank you, Shray. Cool features. So we have a couple of questions here. I'll start with this one. Someone had written that their current EV doesn't do a great job predicting range on mountainous roads, um, and wanted to know if we have a better solution for predicting range when the topography is variable like that, hilly and so on.
Got it. So yes, EVs do consume more range on mountains, especially when you're going uphill, you consume a lot more range. But if you're going downhill, the good thing is that most EVs give you energy back into your system. So this is really great. Uh, we do support a parameter to flexibly program that model for consumption for the EVs. It's called elevation ascent and descent. And with that, you can tell how much extra consumption you expect as you're climbing uphill versus coming downhill. And you have the individual knobs to tune each of those. Think if I have it somewhere here. Yes, this is the docs page. So we call this EV ascent and EV descent. And this would be a parameter that you can program based on the vehicle mass that you have. And EV should be able to take this into account. And as you're going uphill, you look at the road topology which in the Mapbox network, and then we can figure out how much consumption will change.
Very cool. Okay, one more. Sounds like someone might be building an app for delivery or some other two-wheelers and want to know if we support EV range prediction and all these other features for two-wheel vehicles.
Yeah, great question. For two wheels, mostly there are two differences what we typically see. One is the charging network. So for two wheels, most of the cases we see is the batteries are swappable, especially in the Asia Pacific region and also in Europe region, where you can actually go to stations that you can go and just remove your battery and put a new one. So you swap rather than charge. We don't support that data today in Mapbox. However, when it comes to the range prediction, since the EV API is extremely flexible, if you know the approximate or accurate model of your two-wheel electric bike, you can model it through Mapbox EV routing API, and you can get precise range on arrival, and you can know whether you can make that trip in single charge with your current battery levels or not. You can still do that with Mapbox.
Thank you, Trey. We are right at time here. Thank you so much for a great session, and thanks, folks, for the questions. Hope you enjoyed the session, and we will see you at the next one. Thanks again.